Hi guys, welcome back. In this session, I'll be discussing Telangana GENCO, TGGENCO 2024, Electrical Engineering previous year questions. These previously asked questions this year, okay, I'll be discussing about those things. And to be more precise, I'll be discussing about machines, DC machines, and synchronous machines questions. I have already done previously for network analysis, almost 9 questions have come. Power electronics, almost 8 questions have come. And from DC machines, we got 3 questions, I think. From synchronous machines, we got 2 questions. And overall machines, we got something close to 17 questions, 16 to 17 questions overall machines. Okay, so in that, DC machines and synchronous machines, 3 and 2, 5 questions total. And the objective of this lecture is not just to answer the questions. We'll have to answer within 60 seconds. That's the challenge. If you take maybe 3 minutes or 4 minutes of time, you'll be able to answer these questions. But within 60 seconds, how will you able to answer the questions is the key point of this discussion. All right, give it a thumbs up. Okay, if you are ready, give it a thumbs up. Let's get to the first question. Yeah, you try it out first. Those who have appeared or not appeared here, you'll have to be smart enough. You have to answer these questions smartly, okay, so that you'll be making it within 60 seconds. Just give it a shot. Meanwhile, those who are new to our PiSquare, you can visit our website. You can visit our website and check the courses which are available at lowest possible price, okay, and detailed discussion. Even previous year questions also with a detailed solution is given at the lowest price, okay. All Telangana, AP, GATE, 1 mark questions, ISRO questions, all those questions, almost 3,000 questions are there with detailed solution, subject-wise divided, topic-wise, no, not topic-wise, subject-wise, yes, subject-wise it is there, year-wise, full-length test, everything is available in this amazing package. If you want to CL Wadhwa questions, you just try to take this. With this, you will get CL Wadhwa complete questions with a detailed solution. If you're able to answer these questions, if you're able to understand these questions which are there in this package, then you will be able to do almost any question which is given from power systems in state level exams like TRANSCO, GENCO, and all these exams. This package is very much helpful. Okay, let's get to the question, guys. Yeah, I think you must have tried. It is said there is a short shunt DC compound generator. In our course, I think in our YouTube short also it is there. We have made an amazing video which nobody has done it. Okay, just check YouTube short. Different types of connections with the beautiful animation you have seen, and we have developed that animations, how short shunt, how long shunt current is flowing for motor and generator. In 60 seconds, you'll get every one of those, all the connections, all 8 connections of DC machines, you'll get in just 60 seconds. Okay, for motors as well as generators. Anyways, come back to this. It is said a short shunt DC compound generator supplies a load. So quickly, I'm just drawing for the sake of explanation. I have to draw the diagram, so I'm drawing it quickly. Okay. So here you have to be smart enough in taking approximations and approximations. I'll explain what are the approximations. Short shunt DC compound generator supplies a load current of, load is this load, it's generator, so load is this. Here it is 250 volts, 250 volts and 100 ampere. The generator has a following winding resistance. Shunt field winding resistance is 130 ohm. See, the reason why I prefer to draw diagrams for every question what is given is, when I saw this kind of a question, I'm getting blank. Okay. Why do you get blank, dear? This is simple. Let's see how to handle these questions. If you just get into the any course, not necessarily PiSquare course, because these are the basic problems which anyone will explain. Okay. Anyways, first of all, don't think that I'll go blank whenever I see these questions. Don't consider it that way. Okay. Consider that yes, this is my cup of tea. I'll be able to answer this question. You have to think it like that. So don't prepare your mind for something like something not gonna friendly is gonna happen. So don't prepare it like that. Anyways, moving on, 130 ohms, and it is said armature winding resistance is 0.1 ohm, series field resistance is 0.1 ohm. I just try to represent what is given in the diagram so that I don't have to get to this question, get to these lines, get to this text whenever I had to refer to the question once again. So everything, whatever is written here, everything is depicted in this diagram now. Everything, every point. Now it is asked for, find the EMF generated if brush voltage drop is 1 volt per brush. So this EG is a question. It is asked to find out what is EG. So definitely it will be greater than 250 volt. It will be definitely greater than 250 volts. So all the options are greater than 250 volts. So no problem. Okay. So EG is a direct formula. This is the simplest formula. EG is equal to VT plus IA into RA plus RSC, or to be more precise, if you see, this should drop separately because this current is 100 into this much. This drop is separate because the current in this is a little high. Okay. Now, little approximations you can take, of course. Let's try to find out what's the voltage here. 100 into 0.1, which is 10 volts. 100 into 0.1 at 10 volts means this is 260 volts. This is 260 volts. It is given. This is 260 volts. Now current is, this is 130 ohms. So current is 2 ampere. So this current here is 102 ampere. 102 ampere. These are all the numbers which you have done it without any calculator. We didn't use any calculator. We just got to this directly, 102 ampere. Now 102 ampere multiplied with its resistance drop, how much will be this? 0.1 again, so it is 10.2 volts drop. 10.2 volts drop here in the armature resistance. So 250 plus 10 volts plus 10.2, how much is this? Is it 10.2? Did I do something wrong here? Anyway, 10, yes, perfect. 0.1, 10.2, perfect, nothing worrying. So answer is A, because 250 plus 10 is 260, 260 plus 10.2 is 270.2, answer is A. Okay. Now, if you do this, you're gone. Why you're wrong? You're wrong because option A is there. You got 250 plus 10 plus 10.2, you marked it 270.2, it's gone. Because you just looked at this equation. This is a common practice, what we do. We just use this formula. But there is something is given explicitly. What is that given? BCD, brush contact drop. What is brush contact drop? brush contact drop is here there is a brush, here there is a brush. You may have more than 2 brushes sometimes. You may have 6 brushes. Each parallel path has 2 brushes. Upside one brush, downside one brush. So for voltage, when it comes to voltage, one parallel path voltage, if you are able to find out, all parallel paths will have same voltage if you take equalization condition by considering equalization. So this brush is having 1 volt and this brush is having another volt drop. So total 2 volts drop is given in the question. 1 volt per brush means 1 plus 1, 2 volts. So 270.2 plus BCD brush contact of both the brushes, which is 2 volts. So answer is 272.2. All right, good, unique. This is what the solution for this. Okay, and if you draw the diagram, nicely, things will be a lot more easy. You don't have to get to that text actually. Okay, let's go to the next question. See how we'll be able to do these quickly in less than 60 seconds. How to do it? Obviously, once you have a practice, first of all, the moment you see the question, your mind is blank. It does take at least 40 seconds of your time. It will kill 40 seconds of your time if your mind is blank. If you don't want to make your mind blank, you have to make these kind of questions acquainted to your mind. How to make it acquainted to your mind? Practice, 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 practice. How to practice? Where to practice? Come on, yeah, we gave here. Forget about this. This is a complete previous year questions. But if you go for online practice test, what you have for machines, topic-wise tests are there. If you just see electrical machines practice test, yeah, look at these electrical machines. Electrical machines, topic-wise practice tests are there. You can attempt those practice tests. Or when you're doing the course or regular video courses also, there also topic-wise, module-wise tests are there. You try to attempt those tests. So attempting the test is the only way to get acquainted with those kind of questions. All right. So that's the only thing, dear. Do it, do it, do it. Let's go to the next question. This is, mostly in 2024 TGGENCO, these kind of questions have come. These kind of questions are coming. They're given 4 statements. You'll have to check all 4 statements. It's like multiple select question. Of course, it's not multiple select. If this is not given, it would have been multiple select question. Okay, but here options are given, so it has become MCQ. That's it. But mostly, we can find 30 to 40 questions of this nature. Let's try to find out what is the correct answer for this. The self-excited DC generator. See, to understand these kind of questions, you have to know the concept, because upcoming TRANSCO is also a similar pattern exam. So if you know the concept properly, they will not ask you the tough mathematics involved in that. Concepts are very important, or direct formula-based questions they'll be asking. So let's try to understand the concept. Once you understand the concept, you'll be able to answer this question very easily. Okay, but when you're attempting these kind of exams, reading the question is a key aspect. You have to read the question very carefully, only one time. You don't have to spend, you should not spend more time in reading the question once again. So if you don't want to do that, read the question for the first time very carefully. Okay, it is said the self-excited DC generators fail to build up the voltage at no load. Okay, they're failing to build up the voltage at no load. Identify the correct reason from the following. So the moment you read this, your mind should bring some of the aspects. Okay, it is talking about self-excited generator, voltage building concept. Now your mind should be clear. Okay, residual magnetism should be there. I told you, if residual magnetism is absent, how to gain that residual magnetism back by using field flashing concept. I will explain all these points with amazing animations in our lectures. Field flashing, these topics you will not get anywhere. What is this field flashing? All these things are discussed. Okay, why you have to do field flashing, what is the advantage, all those are already discussed. Okay, if you recap those concepts right now, I think now these 4 options you can easily elaborate and opt for all of these. Now if you see, all options are having 1 1 1. I don't have to check this first one because it implied it is true, because all 4 options are having it, and it is known to us Absence of residual magnetism. Yes, if residual magnetism is absent, self-excitation is not possible. Yes. Next, field resistance is less than critical resistance. If field resistance is less, see, look at this curve. You have to imagine this curve, IF and EG. This is the self-excitation process. This is a voltage building curve or magnetization curve. If this field resistance, if we draw field resistance is somewhere over here, then voltage buildup is possible. Field resistance is less means it is slope is bringing down. We are bringing down the slope. Then also, yes, it is possible to build the voltage. But if the field resistance is increasing more, then this goes up, this goes up, this goes up. When it goes up, then there is a possibility that critical field resistance is a critical field value. If it is goes beyond that, voltage buildup is very low. Okay. And yeah, so field resistance is less than critical field resistance is not correct. Then it will not, it will build, it will not fail. Failing means more. That's what is given here. Field resistance is more than critical field resistance, it will fail. Okay, so this is correct, this is wrong. Speed of the armature is, now if you see, this is wrong. So this cannot be the answer. This cannot be the answer because they're having statement 2 also. So these two cannot be the answer. And fourth one is right. Fourth one is right. We'll have to check the third one. Speed of the armature is more than the critical speed. If speed is more, it is good. If speed is less than critical speed, this will come down. Speed is less, EMF is less, this will come down. So this may get like this. You may get like this. If speed falls down below, it will not build up the voltage. Means speed of the armature is more than critical speed. No, this is wrong. In this case, it will build. Means option 3 is wrong. Option 3 is wrong. Okay. So identify the correct reasons. So more than, yes, this is one. Option 3 should not be there in the options. Yeah, it is there. So here it's not there. So speed of the armature is less than critical speed. Yes, these are the 3 reasons why it will fail to build up. So those options are 1, 4, 5. Done. Okay. For explaining it is taking more time, but if you know the concept directly by looking at this, okay, absence, it's gone. It's present. Less than critical speed. Less than critical speed means curve is critical value is here. Less means it is slope is downwards, so it will build, no failing. Then, so if this is done, this is implied. If this is done, this is implied. Okay, these two statements are similar. From one argument itself, you can conclude one, and these two are similar. Okay. Anyways, let's go to the next. Here, the objective guys. See how nicely they're asking questions based on the concepts behind these topics. Okay. You're saying answer is A. Usha Banodhi is saying answer is A. So you're trying to say 1, 2, 3. No. If field resistance is less than critical field resistance, it will build. Why it will fail? It will not fail. No. Next question. Means I mean to say for this, these 3 are the right statements. Fail to build up. Identify the correct reasons from the following. Why it is failing. Okay, careful with this. Anyways, next, that's what I'm saying. If you just go to the concepts, it will be clear. Now, look at this. 250 volts shunt motor takes a current of 41 ampere. Means you have a shunt motor. You have a shunt motor. Quick draw, rough diagram. It is drawing, it takes a current of 41 ampere and runs at 800 RPM. On full load, the armature and the field resistances of this is 250. Armature is having 0.2 ohms. During the stalling of the motor, a resistance of 2 ohm is placed in series with the armature. During stalling means at the starting, EB will be 0. When EB is 0, current will be very high. To limit the current, we will use a starter, 3-point starter, 4-point starter. You can check with amazing animation what we discussed on YouTube itself. There is a video on 3-point starter, 4-point starter, amazing animation video. You can check it out. Okay. Anyways, that we discussed about the starting torque, how to add the resistance. In this case, they added a resistance of 2 ohm in series with the armature, not input side, not input side. At the armature, we added 2 ohms at the beginning. Okay. Then the ratio of starting torque to full load torque ratio, they're asking for ratio. Okay. So for this, if you see, answer we already got from somebody's, okay, I think it's for previous one, Isha. Fine. If you see this, if similarly, you will get the analysis for every question. If you see in the solutions, when you take a practice test, you will get for every question, you will get a detailed solution like this. Every step will be given nicely for you. Every step will be given nicely for you. Every step is, first we calculated shunt field current, then we calculated armature current, then we calculated EB. From EB we calculated K and torque ratio. It's 2.84. Answer is B for this. All right. So if you just appear our test, you will know those steps. Whenever there is a requirement, we will give you some detailed explanation for each and every question. Okay. Next question. So there are the 3 questions which are asked from DC machines. Okay. In DC machines, yes, one is little tough kind of numerical type question. Another question, numerical type question, but easy level numerical type question. Another one is a theoretical question. Now when it comes to synchronous machines, look at this. Look at this. Identify the incorrect statement. See, we have a crash course which is taught in Telugu for Telugu people. Electrical machines crash course is available on our website. You just check it out, that course. You're going to love that course, because in short, we have explained all those concepts with amazing animations. So whoever is having a problem with electrical machines, I recommend you to go for that crash course. Within 20 to 25 hours of questions, 20 to 25 hours of videos, within that span, you'll be able to understand the overview, the gist of electrical machines with beautiful conceptual understanding as well. You just try it out. Try to watch the free videos which are available in that course itself. You're going to love it for sure. Okay. Now coming to this, identify the incorrect statements. Careful. It is asked in the question, what are the incorrect statements you mark it? Sometimes they will ask correct statements. You might be identifying correctly, but you're marking incorrect. Be careful with the question what is asked. Incorrect statement among the following. In a round rotor synchronous motor, the reactive power is maximum at a load angle of 90 degrees. No, if it is active power P, yes, this will be maximum when lambda is equal to 90 degrees, because we know the curve. Like this, alternator and motor. This is for active power, but it's asked for reactive power. Reactive power formula, what's the reactive power formula? Q is equal to Vt by Xs into Ef cos delta minus Vt. This is a formula. This is a formula for Q. Now, in the power equations of this synchronous machines, guys, believe me, it's very easy to secure the marks. Because they are simple concept they'll ask you in the exam. And all these curves, all these kind of questions, all the related formulas are very clearly discussed in the course and given the detailed notes, so that you will never miss those points if you even take the notes exactly. The notes is also so powerful. All our lectures, we're teaching something, and after the lecture, we are providing the notes for that particular lecture only. If you take the note of those lectures, by copying those given PDF, you're going to rock it. You don't have to put your extra brain in writing it. All the text, whatever is there, all the points, whatever is given in the video is given in the PDF itself. Okay, so your mind has to be focused on to grabbing the concepts, grabbing the understandings of these machines, grabbing the idea of the machines. That's it. That should be your focus, because that's what the PiSquare tag, and we help you in bridging the gap with the multiplied effort. Means we'll take care of everything. What you'll have to take care of is you'll have to take care of just putting your attention. That's it. All these animations, what we're doing by the animations, we are giving that visual effect for you so that it will be easy on you. All these formulas we are giving you, all the notes we are giving you, so that you don't have to waste your time in thinking about the notes. No, notes is already there. You have to write it. If you don't write the notes with your own hands, you're not going to understand the concept. Taking a printout, taking a Xerox, it's not going to help. You have to write it. Given the given notes, you have to write it. That's a motto. That's the tagline of PiSquare. We always stick to that vision. We always stick to that point so that it will be easy on you. Anyways, so this point, even when I'm giving this table, I used to give each and every point. Delta should be when delta is equal to 0 degrees, then Q will be maximum. I have given this explicitly. Q is equal to maximum when delta is equal to 0. If you are confused, if you just know this equation, then also you'll be able to make it. Then also maybe 30 more seconds extra you may take it. You can get it dq by d delta. When this is equal to 0, then Q will be maximum. In the differentiation, this is constant, it becomes 0. Cos delta means derivative is sine delta. So sine delta should be 0, means delta should be either 0 degrees or 180 degrees. 180 degrees is not possible, so 0 degrees. So this will be maximum when it is 0 degrees. So this is a wrong statement. And it is asked for identify incorrect statements. So this option is wrong, this option is wrong. Only A option, D option is left. A option, D option left. Now I don't have to check question option 3. Option 3 I don't have to check. I can blindly strike out this option 3 because it is common in both of these. If I check either 2 or 4, I'll be able to mark what is the right answer. If I check either 2 or 4, I'll be able to mark the right answer. That's it. Now let's see. Damper winding is provided in a polyphase synchronous meter in order to provide a starting torque. Absolutely correct statement. This is absolutely correct statement. Damper stating, of course, will prevent the hunting phenomena. It will also provide the starting torque required. It has a dual advantage. Hunting phenomena, it will reduce. It will also produce starting torque, because we know in case of a synchronous motor, starting torque is 0. You have to use an external motor. Pony motor we'll have to use external DC motor to run the to start the synchronous motor, but damper winding is there to start it. So this is a correct statement. So this option cannot be right. Option D is right. Without checking a fourth one, we already mark it. We already made the option. But let's check it out the fourth one as well for the sake of understanding. Synchronous condenser is an overexcited synchronous motor. Absolutely true. Overexcited synchronous motor, till this is absolutely true. Driving a mechanical load, no, this is not wrong. This part is making this statement wrong. Synchronous condenser means it is an overexcited synchronous motor at no load, when it is operating at no load. That's what the difference between a regular synchronous motor and synchronous condenser. You're calling a synchronous motor a synchronous condenser because there is no shaft extension for the synchronous condenser. Synchronous condenser has no shaft extension. Means you have no provision even for a synchronous condenser. You have no provision even to connect to the load. Mechanical load you cannot connect because shaft is so short. It is designed explicitly for synchronous condensing. If it is synchronous motor, yes, you can use it for motor purpose, as well as you don't apply any load. It will act as synchronous condenser. So this point is making the statement wrong. So 1, 3, 4 are wrong statement. 1, 3, 4 are wrong statement. You mark this. Now if you see how nicely all these points are explained in this, you will have a solution like this. In a practice test, you will have a solution every point. The formula is given and what's the condition is given. Each and every statement, first statement, second statement, third statement. Look at this. Third statement we have not seen. Let's check it out because as it is common in both of those, we marked it smartly. But what is the third statement if you see? In slip test on a salient pole synchronous machine, the EMF induced in the field winding is 0 for a quadrature XQ. No, it's not 0. It is a maximum EMF induced in the rotor. See, that diagram, that explanation is nicely given here along with the diagram. This is a diagram. Q-axis where EMF induced is maximum. And it is armature voltage, the envelope inside that armature current nature, armature voltage nature. So along the Q-axis, this will be maximum, this will be minimum. Armature voltage is minimum along Q-axis, along D-axis it is maximum, it is minimum. So we have given this extra information also so that during your learning process, during your practice process, you'll be able to recap, you'll be able to revise a lot of concepts by looking at these solutions. Okay, so this solution, analyzing the test is very important. You appear the test, whatever the marks you might have got there, analysis, you may take maybe half an hour to appear a test, but it may take 3 hours sometimes to analyze the test, understand this test, do the corrections to your own mistakes, what you have done. That's very important. Okay, next one is with the usual notations, whatever is given with the usual notation, the following phasor diagram corresponds to. See the amazingness, beauty of this question. And these points also, even including this question also, is discussed in our course. This question also, previous question anyways discussed, this question is also discussed in our course. The concept behind this, every point is discussed in our course. What is the point here? With the phasor diagram, how one can say whether it is alternator or generator? Can we say? Yes, we can say. It has been taught. It has been taught in the course in a simplest way. There are a couple of ways. One of the simplest ways in a generator. All of you must be answering this. In a generator, or to be more precise, in an alternator, I want an answer from every one of you. I'll ask a simple question. In an alternator, what is the initial voltage which is coming up? Is the induced EMF comes first or terminal voltage comes first? Induced EMF comes first or terminal voltage comes first? In an alternator, the purpose of alternator is to generate the voltage. So it is first inducing the EMF, then it is giving it to the terminal. So this comes first, this comes next. Means this will always lead because this is coming first. After some drop, then there will be VT. So always this is first. So leading, this is leading, yes. Then after VT is there. What normally, there is a point to get confused here. The point is, you may see VT is a little longer, EF is shorter. EF is short, VT is long. You may say VT is long. After some drop, you are getting EF, so it might be motor. There is a chance to get confused. Don't think about all of those because synchronous motor, you have a power factor also having an effect, armature reaction also, leading, lagging, magnetization, demagnetization. The values may be anything. Don't think about the values. Think about only the angle, delta. With respect to this is a reference. With respect to this, EF is leading. EF is leading means alternator. Synchronous motor, wrong. This point is given in our lectures also. Okay. Next point is whether it is underexcited or overexcited. How to know whether it is underexcited or overexcited? Look at this. This is leading. Because VT is here compared to VT. IA is leading. Means power factor is leading power factor. I said in case of any synchronous, any exam when you go for it, from V and inverted V curves, there is an 80% chance, directly or indirectly, directly or indirectly, 80% of chances are there you will get a question from V and inverted V curves. So with the same concept, with the same V and inverted V curves, you'll be able to answer this question easily. Because let's look at this. Let's look at this. Yes, solution. The similar solution is given there for you also in the practice test. If you see V and inverted V curves of an alternator, yes, this is a V curve and this is inverted V curve, and this part is a leading part. When current is leading this part, when current is lagging this part, if it is a synchronous motor, this will be reverse. Here it is leading, only Q is same. Q is same. I mean to say, only this part will go here, this part will go here. Q absorb here, Q deliver here. That is not going to change, whether it is a motor or generator. But when it is a motor, here lagging, here leading. But it's also for generator, so this is leading, this is lagging. Means leading we have understood. Leading case is under excited case. Leading case is under excited case. So it is under excited alternator is a right answer. Okay. So these questions, out of that torque question, except the torque question, other questions are you can mark, you'll be able to do it very easily in a short time. Okay. Torque question is little torque ratio question is little lengthy question. Yes, what to do? It's given in the question, it's given in the exam. Okay. So if there is a further questions, feel free to contact us on WhatsApp or visit our website. Check out our free lectures. A lot of free lectures are available. Check it out with amazing animations. You'll get all of the lectures. Okay. So you're gonna love it for sure. At less price, you'll get the lectures and the practice tests are available. Attempt the practice test. Free test or paid test, whatever it is, you must attempt the test. Start your preparation. Start your preparation. Finally, I'm gonna ask a question. I'm gonna ask a question. You should answer this question. You should answer this question. The question is, I always ask this question, when you should start your preparation. When you should start your preparation. Option A, when exam notification comes out. When exam notification is out. Option B, after I apply for the notification which is released, which is out. Once the notification is out, then only you should start your preparation. That's option B. Option C, once I failed in the attempted exam. In the attempted exam means you have attempted an exam, you failed that exam, then only you should start your preparation. This is option C. Option D is, what is option D? Option D is now. You should start your preparation now. That's option D. Now, what do you think what you should do? What do you think what you should do? You just give your answer in the comment for this question number 7. Take this question number as 7. Give the answer for Q7. Whatever is answer. If your answer is A, type A. If the answer is B, B, C, D, whatever your answer, answer it. That's the end of this lecture. Happy learning. Enjoy the